Hey there. So this is Dr. Dave, and I am talking today about measurement issues. In a previous session that I did, we talked about how to calculate the correlation between two variables. We graph the variables. We can and we assess the reliability of those variables, looking at the intercorrelations between the items that make up a scale. One important aspect of looking at a scale is to think about its various dimensions. And usually, we, in various respects, we like to regard a scale as being unidimensional. So it's not always the case, but you can look at the multiple dimensions of the scale. But it's nice when you're just saying, here's the correlation between self-esteem and depression, or between neuroticism and procrastination, to be able to say that these are unidimensional scales and that there's not multiple dimensions broken up within those. Today we want to take a look at that, and so I have a couple of scales here. I open up this file. It's called lab 7.1 depression.save, and again, this is from a data set that I collected back in the 1990s. It has, let's see, going down to the bottom here, 421 observations. There was originally 448, but this data set has been cleaned, and in the cleaning process, some of those subjects were removed from the data set. And so we have the ID numbers, gender. I have scores in here without the specific items and computations, but something that you can potentially play around with. Their neuroticism levels, extroversion, openness to experience, agreeableness, and conscientiousness, using short handles or variable names for those. And then we have depression. Depression is measured using what's called the Center of Epidemiological Studies Depression Inventory. It's called the CESD, and here I have used a shorthand for it by this labeling it CS, and it's CS item 1, CS item 2. You can see when I put the cursor over it, since we entered in the variable view a label for those variables, that it shows up, that label shows up as I hold the item, the cursor over the item label. And some of these were asked in the opposite direction, but they've already been recoded, so we don't have to recode any of these. You notice, like here, this one was worded, I felt hopeful about the future, but I have a notation there in the code that in parentheses R means that I've already recoded that one so that you don't have to recode it. What I mean by recoding is that if we're basically saying that all of these items contribute to depression, let's take a look down over here. Let's look at the variable view. If I'm wanting to add these up so that, 0 means not depressed, and going up to a maximum of 3 means most of the time they were experiencing this, so that means more depressed, then I want all the items to go in that direction. Well, that's going to work for I was bothered by things that don't usually bother me. I did not feel like eating. My appetite was poor. I felt that I could not shake off the blues, even with the help from friends. I felt that I was just as good as other people. Now that one's a positive item. And so if we put a 3 in there and added that up for our depression inventory, it would be, if the person said most of the time, then that would indicate more depression. So I want to change that 3 into a 0 by virtue of recoding it. And I've already done that. So these items can simply be added up. Okay, you'll notice that there's 1, 2, 3, 4 items in that measure of 20 that was recoded. What we're going to be looking at is the correlation here between depression and self-esteem. And self-esteem, there's 10 items here, and 5 of those items are written in the direction of low self-esteem, and 5 of the items are written in the direction of high self-esteem. We're going to need to go ahead and take the ones that are written in the direction of low self-esteem and recode those so that they're in the direction of high self-esteem. And we're going to show you that recoding process as well as the process of getting the means so that we can ultimately look at the correlations between these two scales. But first I'm going to start off by just looking at the reliabilities to see if the reliabilities of these items are high, just like we did last time. So I'm going to go to Analyze and Scale, Reliability Analysis. I'm going to go ahead and display variable views here. I'm going to take all 20 of those depression items. Remember, I'm going to get descriptives for the item, scale, the scale if the item is deleted, and the correlations. Okay. Up comes my output window when I run a executable command. Remember, any analysis command is an executable command. And so when I run the analysis command, it comes up, remember, SPSS has 3 windows that you typically work with. The data window here, a output window, and then you can also have a window for code. And in fact, I have that open over here. Here's a window for code called a syntax window. The syntax window will have the name. So I give it a name like depressed. It puts on a subscript, a suffix of .sps. So a .sps is a syntax file. A .sav is a data file. And I think an output file is going to be like a OUT. I don't usually save those. We'd have to save it to actually see what the name is. I just usually just rerun my analysis and then copy and paste the pieces that I want from that output into a Word document or a PowerPoint document, wherever I want to go ahead and make that output look pretty, or save it for transfer to a table, whatnot. Okay. So going back to our output file, the Cronbox alpha here is very healthy. It's almost a 0.90, so a 0.8 and above would be a very good alpha. You notice that, though, not all the correlations here are extremely high. Like this one here with I felt that I was just as good as other people, did not correlate well even when recoded. So it would basically mean I did not feel as good as other people. It's recoded. Was barely correlated with poor appetite. Poor appetite was barely correlated with the number of items, especially those positive items. You see that the correlations overall, a lot of them are low and in the weak, but there's a lot of items, and lots of items helps contribute to a positive alpha. None of these items are doing extremely poorly. Where's our poorest item? Maybe the poorest item is I felt that everything I did was it should be an effort. I'm sure in the original data set that was inputted correct, but in putting these in for use so that you could see them, I think there was some mistakes in terms of how these were written, but that's written pretty badly. I felt that everything I did was an effort, was as effort. The real item was I felt that everything I did was an effort. So, but that has only a 0.298 correlation. Basically saying you might improve Cronbach's alpha just a tiny bit, but for that tiny bit of a improvement, I wouldn't bother taking it out. So I don't see any real problems here, but it's not like the scales that we did before where the correlations were simply all strong. Remember, correlations around 0.1 are considered weak. 0.3 is considered moderate. 0.5 and above is strong. So we have weak, moderate, and strong correlations in here. And some of the correlations are even close to 0. Okay, when you have correlations that are somewhat weaker like that, then that's an indication that there might be multiple factors in there, even though the alpha is strong enough to go ahead and say we could treat this all as a depression scale. You might want to check out and see, well, you know, what are there multiple dimensions of depression to be had in there? And we can do that by doing what's called a factor analysis. So I'm going to do a factor analysis here. I'm going to go analyze. I'm going to go to what's called dimension reduction. And then factor analysis. I'm going to right click, display my variable name so that I have that CESD1 down to CESD20 and plug those in. I don't think we need the initial descriptive statistics. We had that from the previous analysis that we did. I'm going to go with what's called, I'm not going to try and explain all the differences here. I'm just going to go with what's called principal axis factoring. I'm going to do what's called a scree plot. And continue. For my rotation, I'm going to go with a Promax rotation. I know you don't know what these are, and I'm just not going to try and do a complete lecture on factor analysis because that can take an hour. And I just want to go through kind of a common way of looking for multiple dimensions. And just briefly what we're doing here is the Promax rotation is one way of saying that if we have multiple dimensions, we're going to allow them to correlate. We're not going to force them to be uncorrelated. We're going to allow them to correlate, and we're going to take a look at the size of the correlations between them. I'm going to go down to options, and I'm going to sort my results by size. And I'm going to suppress small correlations. And I'm going to suppress them at 0.3. And then I'm going to run that. Okay, this is a complex analysis, so there's a lot I'm not explaining. But what this analysis just did is it basically started to say, is there ways of taking these items and forming an algorithm where I basically combine the items into like a single factor to try to capture as much variance, as much as what's common among all the items. Remember, all these items are designed to get at depression. So what we're trying, so you would think that there's some things common to depression. And so this is a mathematical algorithm designed to try to get at what's common to depression. And what it's coming up with here is that first factor that it's able to come up with gives us 35% of the common variance. Then there's a second factor that gives us another 9% of common variance. Then another factor, a third factor, that gives us 5.7%. And then a fourth factor that gives us 5.1%. And you can keep going, but remember, we're getting smaller and smaller amounts of unique variance. And at some point, the amount of unique variance that we're getting is less and less useful. It's more what we might consider error variance, unique variance, something that's separate from depression. You know, appetite was one of the issues coming in there. Now, appetite can have something to do with depression, but appetite obviously also has something to do apart from depression. You're just getting, sometimes people get hungry, and they have this kind of on a regular basis, right? And sometimes they're not hungry because they just ate a lot, or if they were sick, that could also throw off a person's appetite. There's things other than depression that can result in a poor appetite. And these unique variances are at some level getting at those things that are far away from depression. So we just want to go with the first ones that are capturing a good amount of common variance in hopes that those are capturing things that are core to the idea of depression. And usually when you get around 54% of the variance, somewhere around 55% of the variance, you're usually capturing a good amount of the common variance that you would expect to be capturing. Now, the way that the computer did this was that it was set up as a default. This is a kind of a common default for this analysis. That these percentage of variances are captured in something called an eigenvalue. And basically, if the eigenvalues are 1 or greater, then it basically says that's going to be a factor. That's capturing enough of this common variance that I'm going to keep it. And then beyond that, I'm not going to try and keep those, because that's getting at those unique things that are probably a little bit separate from the core construct that I'm working to capture. So now I go down here to what's called a scree plot. And the scree plot can also be useful in terms of telling you how many factors you have. The scree plot is saying that there's definitely 1 factor, then 2, then 3 is usually the way people would read the scree plot. A lot of people don't like the scree plot. They talk about this as being an elbow, right? You know, think about an arm, and you know where it kind of turns, where there's an elbow. You're basically wanting, you know, to get the top part of the arm, and then the elbow. After that, you basically throw that away. You thought I did throwing away that part of my arm, but you get the idea. So here it looks to me like there's 3 factors. I think we can keep the 4 factors. So let's take a look at interpretation wise the way this came out. So it's given us the variable labels, which is handy, and it's showing us the factor matrix, and here it's showing that everything loaded onto factor 1 initially, and then here was factor 2, factor 3, factor 4 only had 1 item. It seemed to be loaded onto it. But this is an unrotated form. And now there's a lot that goes into this notion of unrotated and rotation forms. This first form is not really good for interpretation. So what we want to do is look at what's called the pattern matrix, because the pattern matrix actually rotates it. And let's look at what's going on with this pattern matrix. So the pattern matrix, first of all, the first factor gives us items such as I felt sad, I felt depressed, I had crying spells, I felt lonely, felt that I could not shake the blues, I was bothered by things, I felt fearful, I did not feel like eating, my appetite was poor, my sleep was restless. It's giving us emotional and physical symptoms. Now, I've seen some results from factor analysis of depression separate the physical symptoms as one factor separate from the emotion, but it's just coming out here. It's combining those. What's it doing over here? Here it's putting in all those positive items. That's not surprising. Lots of times when you have items that are reverse coded, they will often come out as a factor unto themselves, even when they've been reverse coded. And some people really dislike putting in reverse coded items for that reason. Now, the benefit of putting in reverse coded items is that if people are getting tired of filling out the scale and they just start going, oh, all these are going after depression and I feel really depressed, so I'm going to put 3s on everything. Or I don't feel at all depressed, I'm just going to put 0 on everything. Well, the reverse coded items catch that, right? That's one of the real benefits of doing reverse coded items, is that you would be able to see that the person just did 0s, and on the reverse coded items, that doesn't make any sense, that they would be completely undepressed. But now on the reverse coded items, when it said I enjoyed life, they were saying they didn't enjoy life at all, right? They weren't at all happy. That would not make sense. So that would be a big flag. So an advantage of reverse coded items is it keeps people actively engaged and allows you to tell if they were not paying attention. But the downside is that it often gives us a factor by itself. Then we have over here, so here was kind of like, these positive thoughts about enjoying life in the future. And even one negative item loaded on there, I thought my life had been a failure. So all of these are kind of like evaluating life, and that this item gets thrown in there with those positive items because most of those positive items are kind of like evaluating life. And then this third factor, I had trouble keeping my mind on what I was doing. I could not get going. I felt that everything I did was an effort. Well, those are motivational deficits, and motivational deficits have often been considered, separate from a subcomponent of depression. And then people were unfriendly. I felt like people disliked me. Here we're getting into social deficits. So those make sense that those could be separate components of depression. How do those components correlate with one another? If we go down to this factor correlation matrix, it's basically saying here we have four factors. It went ahead and it basically used this structure matrix to compute correlations I'm not actually sure. It's actually a version of the structure matrix as opposed to the structure matrix itself. So I shouldn't have said that. it spits out a different. There's another version of these matrices that gets spit out for creating the factor scores. But anyway, you take those 4 factors, and here they are. You know, the moods, the positive views for life, in reverse coded, so it's really kind of negative views for life, the motivational deficits and the social deficits, and they're all correlating pretty highly together, right? None of these are completely separate from one another. The end point of this is that there are 4 factors here. They're a little bit separate. It's getting at 4 dimensions of depression, but these dimensions of depression all correlate pretty strongly together. And that indicates that it's probably okay to just use these 20 items as a single measure of depression, but there may be, under certain circumstances, some advantages of looking at them separately as well. So if you had some factors that simply weren't correlated with one another, like the correlations were down between 0 and 0.10, or really, you know, the really low correlations, you know, low, you know, 0.10s, 0.20s, that would indicate that, you know, you really probably shouldn't be combining these scales together. That the constructs are all, the concepts embedded within depression were all just a little bit too unique. Okay. One thing that we can do here is we might, you know, want to see, you know, what these items look like. Double click on these. Give me just a moment. Okay, so if you want to see the variable numbers, variable names, so that we have the numbers so that we can actually do computations to put these, you know, to calculate the different scale scores using syntax, then what you can do is go up to Edit, go to Options. It will probably come up General over here. Go over to Output, and then over here, this was going to be labels. I just switched these. I'm testing it. Trying to remind myself how to get both of these. There's a variety of ways, and I think newer versions allow another way, and I'm using kind of an older version here, but you can switch this to names and labels, or just names. I'm going to go with the values and the labels, and then hit OK. And now we can rerun that. Now, an easy way of rerunning the analysis is this box right here. This box, you know, if I hold my cursor on it, says Recall Recently Used Dialog. So instead of going back over to Analysis, Dimension Reduction, all I have to do is go here. I just recently did a factor analysis, so it comes up, all the same settings. Hit OK. It reruns it. But this time, it's rerun it to where it says that I have item 18, item 6. These are, you notice these have the highest loading. So I felt sad, I felt depressed, are kind of like, you know, the main indicators of depression. That shouldn't be, you know, too surprising. It gives you the items now that you can work with. And so in order to form a subscale here, what we would want to do is add up average items 11, 21, 10, 1, 3, 14, 17, 6, and 18 to form that emotion and physical symptom subscale. Okay. I'm going to go ahead and pull up my syntax file for you. And let's see, in the syntax file, I didn't actually compute all of those unique depression variables. And as this video is already long, I'm going to go ahead and I'm not going to do that because I still have another important thing to show you. So I'm not going to show it to you, but it seems kind of weird not to show it to you after we just went all the way through that. So what I could do is go ahead, copy. I wonder if this is going to work. And put a little bit of area here and paste. And it actually is showing me the numbers so that I can see I could form, compute the emotion equals me, remember this, making up a name, and I have CES 18, CES 6, CES 17, CES 14, CES 3, CES 1, CES 10, CES 2, CES 11, and that would be the end of it. End period. Now I know that's the case because these, on the pattern matrix, these started off with high ones and went to they were low. And I remember from the previous results that gave me my first dimension. And then it starts over with the second dimension being high and then going down to low. And so compute for depression, and I'm going to call this my cognitive factor. It's kind of the cognitive outlook, how people were thinking about life. The mean of CES 16, CES 12, CES 4, CES 8, CES 9, and CES 5. And there's my second dimension. My next dimension, if you remember, was the motivational component. So depression motivational component, mean, CES 5, CES 20, comma, CES 7, CES 13, and CES, and that's it. That's the motivational component. I noticed that there was a CES 13 over here. It didn't actually come up with a loading, so it didn't actually successfully get onto any dimension. If it was going to be put on the dimension, I'd put it on to that social dimension, but I'm going to go ahead and leave it off since it did not have a loading of 0.3 or higher. You remember earlier on when there was an option that I said 0.3 or higher? What that did was to only allow a dimension to show up as loading if it had a correlation of 0.3 or above with the dimensional score. And so this is depression, and this is my social dimension, and it's mean CES 15 and CES 19. And there we go. I'm going to go ahead and show you, so you know exactly what this means when I'm using this mean command. It's the same as going compute B social 2, really desocial 2 is the same as desocial 1, and this arbitrarily given it a different name. And one way you could have done that would have been to say, hey, let's add up CES 15 plus CES 19, and since there's 2 items, divide by 2. So I have 2 items, I'm adding them, summing them, dividing by the number of items that I have, which is 2, and that gives me an average. But instead of doing that work, it's easier to just use this mean function. It just says, hey, get the average of these. So get rid of that. But that's basically what we're doing when we're asking it to calculate a mean. Okay. So here's the compute statement for my whole depression score. This says take and add all of them together and get a depression score. And from what we've seen, that should be okay because the subscales correlate pretty highly together and the alpha was really high. We also need to calculate our score for our self-esteem scale. And because I'm already at 36 minutes, I'm going to call this first this first one my factor analysis video. I'm going to cut this video short. 36 minutes is not exactly short. I'm going to go ahead and stop it now. I'm going to come back and do the rest of this as a separate video. Thanks a bunch. I'll be back with you. Bye.